Okay. So as we said, this today's lectures, we start with the data query using, again, SQL with R. Yeah, so that's our main goal today.
Professor, okay, sorry to disturb, Professor. Can I ask you?
Yeah, go ahead. I'm listening to you, please.
Yeah, Professor. We have 4 more students to present the presentation, right? So,
Oh, if
uh,
that's the case, hopefully,
just reminding you.
yeah, I know already. So hopefully to be, if it's not today, surely to be next week. I think like
Okay.
two students or so. Yeah, I think no, so around 2 or 3. But
Oh,
again,
4.
I know already. So yeah.
Yeah, okay, Professor.
Mm. Because time couldn't permit us to finish, so I remember last week. Okay, so as we said today, my voice. Okay, so as we said, our main objective in this lectures is, first of all, we are going to go through SQL, basically introduction to SQL. As we all know, this is not a database class, so we are not going to go much detail about it. So we are going to define some few terms, also define a database using SQL data definition language, and also write a single table queries using SQL. And I think, as we said earlier, with our main focus will be using queries, especially select statements. That's the same as Java. We have as we said, the JDBC. We normally connect it with a database system. Most of the time is queries we are going to use, because queries or select statement allow us to get some data that we need based on some criteria if we set it up. Yeah, so again, we are going to write the SQL statement also in R. We're going to see the example. And basically here, we're going to focus on using the select statement. Actually, this go in sequence, select from where. So you select from what table, the where will be the condition. We also will see how to use the is, like, order by, which is sorting, limit, we can find mass, and main SQL functions. So that's why I highlight here red. This is our main focus of the syllabus objective. But again, we start with the introduction first. So here we start with the definition. First, what is a database? So here we say it's organized collection of logically related data. So a database, in short, I would say it's a data that we save in a computer system, also electronically, again, save in a computer system. So a data will be the store representation of meaningful objects and events. So example of a data can be my last name or my first name, address. And also we have 2 types of data here. We have the structured one, for example, like numbers, text, and date. Then we have unstructured data, for example, images, videos, and also documents. Now, what is an information? So information will be the data that has been processed and it, again, have a meaningful, or yeah, basically it's data process to increase knowledge in the person using the data. So to give some meaningful, I'll say, knowledge. For example, if I have a driving license, or we have a driving license, we say, okay, uh, the driver last name and first name. Yeah, that will be individual data, last name, first name, address. But when we combine all together in the driving license ID, I would say it become an information. We know that all this information is related to the person who the state has given privilege to operate a vehicle. Yeah, so that will be so in short, we will say that again, information will be a data that has been processed. So data process to increase knowledge in the person using the data. And also we have the terminology named the metadata. This will be data about data. So data that describe the properties and the context of user data. So that's an example of a database man. So a database management system will be the software that we use, in this case, to create, maintain, and also provide control access to user databases. So a very nice diagram here shows, for example, we have some applications here or some or I would say first order filling system, invoicing system, payroll system. These will be individual functions that we can perform. But all the data here in all these three sections will be saved in our central database system. But we need a DBMS to again manage all this data also. So DBS main goal is to create, and most important also to manage and efficiently manipulate the data. For example, DBS gives us one of the important features, which is a select statement, or to be able to write a query, which I think is very important. Example like Amazon database system may have millions of customers all over the world. Well, if we need a customers that based on some state or some country, or they spend more than $1,000, well, I don't want to take my time, or the data entry person may take his time to go through all the millions of data to just select whatever criteria it's looking for. Let's say it's looking for all the records, all the customers and that make a purchase over $1,000 in New York State. So you don't want to go through all the whole country. So in this case, I can just write a select statement, a query that will give me that result within a few seconds. So again, query is very important. So what are the advantages of a database management system or approach? Here we say the program data independency will be one of the advantage. Also redundancy. Data redundancy is a lot far better because again, in database management system, when we design our tables, normally we can put the table in the first normal form, second normal form, third normal. That's what we are doing is trying to again put the tables, or in this case, the data in the right place whereby redundancy issue will be resolved. And also we have something like a primary key field for each table. And this primary key field will uniquely identify each record. So we don't want to enter the same customer 20 times because he bought 20 items, because his customer ID is the same. So in this case, I may have a table for items. So there, and that table items, maybe the items ID will be the primary key field. And if these two tables are connected, the customer table and the items table are connected together, maybe it's going to have a one-to-many relationship, which means if I buy 3 items in the customer table to show only one customer, but in the items table to show the 3 items that you bought. Again, that's the concept of data consistency, sharing, etc. So these are all the advantage. Also, want you also to improve data quality. Now, the element of a database approach, normally, as we said about the process of, again, coming up with the tables, creating the data, etc., we have to design. We needed so we start with the models first. I think we have one of the special model that we call the entity relationship diagram. So we can use the entity relationship diagram to be able to, again, come up with a very efficient or best, again, database system. But again, that will be the model. So we say the data model is a graphical system which will capture the nature and the relationship of the data. So again, a good example will be the entity relationship diagram. Because the entity relationship diagram, we're going to identify all the entities and also the relationship between all the entities. So here we say the enterprise data model, high-level entities and relationship for the organization, and also the project data model, more detailed view, also matching data structures in database or data warehouse, all will be again captured within the data models. So what are the entities? Normally, the entities later becomes a table. And most of the time, the entities will be a noun. For example, a person, student, products, etc. So example, here we say, so now if we are given a question about to design a database for a specific company, the process of doing it, let's say with the city banking industry or moral college or educational institution, the process will be the same, but most likely the entity's name will be different. In bank, maybe customers; in school, maybe students, institution, etc. So again, now we form the form describe the person, place, object, event, or concept, which will be composed of attributes. So we can also say the attribute will be the characteristics of that object. For example, a person, the attribute can be last name, first name, address, items, item order, or item ID, item name, if we need a weight for some reason, etc. Then we should have a relationship. Normally in database system, we have three major relationships, but the common are these two. And we may have one to many, and also we may have many to many, and we can also have one to one. But very rare we use one to one. Majority we use one to many. So sometimes when it's many to many, we can decompose the table and we form one to many from it. Now, relational database, the whole concept relational, as we mentioned, is about relations. So this is a database technology involving tables, relation representing entities, and also we may have the primary foreign keys representing relationships. Normally, a foreign key will be a primary key in another field. So if I have two tables, let's say student and course, if I'm creating the relationship between these two and I'm using student ID, student ID will be a primary key field in a student table, but it will be a foreign key field in a course table. So normally we need a foreign key and primary key to represent a relationship between two tables. So that will take us to SQL overview. Some people pronounce this SQL or SQL, but I always say SQL. I'd say, and it represents again structured query language. This is again standard for relational database management system. And as we mentioned earlier, we have the definition for relational database here again, which is a database management system that manages data as a collection of tables in which all the relationships are represented by common values in the related tables. Let me wait for a few seconds if any question. Okay. Now, what's the purpose of SQL standard? I think the key word here will be standard, because again, we have so many proprietor or say different companies coming up with their own database system, like so many. Let me mention Microsoft have its own database system, Oracle have its own databases, and other companies. Now, if they are all using their own standard, it will be difficult for portability issues. So this means if I have a system with Oracle and also, let's say, Microsoft Access or MySQL, they can work together. Maybe each one will have it. So that's not a good thing. So we have SQL standard so that, again, this will be more industrial or more universal language for database systems, especially relational database system for SQL. So here we say first is to specify the syntax and also the semantics for data definition and also manipulation. Also define the data structures and the basic operations. The keyword here is also to enable portability of database definitions and application modules, regardless of what company is developing the database system. Hopefully, two or more companies, they can use the same language. Also, it specifies the minimal level 1 and also complete level 2 standards. And also, it allows for later growth, also enhancement to standard in terms of referential integrity, transaction management, user-defined functions, extended join operations, and national character set. We will not talk much about this because, again, mostly this will be covered in a database class. As we all know, this class is the concept of using R. So that's what we focus on. So the benefit of standardized relational language, here we say to reduce training costs. So if it's a standard language for the industry, if one person is using Oracle in one company, you use the same SQL. Another person, or even studying a school, is the same SQL. So if you learn it once, whether you are going to use Oracle in one company A, or you're going to use a Sybase or in a database in company B, again, the same SQL standard. So it will reduce the training cost. Productivity will be good. Application portability, I think that's the key. So, and also application longevity also. So this is what we have mentioned a lot, reducing the dependency on a single vendor. So again, the SQL is the standard industry. And also cross-system communication. So hopefully Microsoft Access with Oracle, they can communicate through SQL. Okay, so this is the SQL environment. First, we have what we call the catalog. This will be a set of schemas that constitute the description of a database. Then we have the terminology schema. This will be the structure that contains description of objects created by a user. Example can be tables, views, and constraints. Then we have the data definition language. This will be the commands that define the database. The measure is creating the database or the database objects. We use the command from the data definition language. If we want to alter or establish a constraints, like primary key, foreign key, etc., whatever constraints, again, the commands are in data definition language. And this is where we are going to focus, data manipulation language, where we can write commands that maintain and query a database. Then we have the security issues, which is the data control language, commands that control a database, including administering the privileges, also committing data. So these are the SQL data type. Again, this is very standard. So we have the string, number, temporal. Temporal is related to time. And also we have the Boolean, which is either true or false. So within the string, we have character, some few, and now this is based on the size. So for example, a character char will store string values containing any character in a character set. The char is defined to be a fixed length. And then second, store string values contain any character set by definable variable length. Again, depends the size. Integer means a whole number. Wait for a few seconds if any question. Okay, let's keep going. So this is our DDL, data definition language, data manipulation language, and DCL. So these are some few examples given. For example, in a DDL, as we said earlier, we can create a table. We can create a concept of indices, views. Also, we can establish foreign keys. And also we can drop or truncate tables. Now with the DML, which is where we're going to focus, we can load a database, insert data, update the database, and also manipulate. That's the most important thing we're going to do, manipulate the database using the select statement. So this will be the implementation. And also DDL can be physical and also for maintenance of the database. Then DCL also is implementation. Also, we use it for maintenance also. So for example, grant, hard, revoke. Also, so next is the data definition language. So the major is create statement. That's the major command. So we can create a schema, which will define a portion of the database owned by a particular user. And also we can create tables. We can create a view and other create statements. For example, character set, translation, collation, assertion. But again, in our lectures, we are not going to focus much here. As we said earlier, again, this is for database class. Our class is R, or statistics using R. So again, steps in table creation. This is for the homework. As we said in homework assignment, you have to create at least one table. So first we need to identify. So you come up with your own, what kind of database, what industry you are going to use. So you come up with your entities or your table. Let's say student table or customer table or product table. Depends the organization. First thing we need to identify is the data types for the attributes, and also identify the columns that can and cannot be known. For example, the primary key field cannot be known. Those maybe last name, first name, if you like, you can say it can be known. Or also we can set it that it cannot be known because we need to identify each customer last name, first name. But I would say, no, okay. If we know the customer ID, then we know the first name and last name. Again, it's up to you how you come up with your design. The next one is to identify the column. So this will be that must be unique. So this will be the primary key field. And sometimes we may have a table and we can call it a composite field. A composite field means only one field cannot uniquely identify the record. So we may need two fields or more. So here we just have to identify all the possible candidate keys. Then we identify the main one, which is the primary key. Primary key, as we said, can be used in another table, and that table will be a foreign key. It will be called foreign key in another table. Then if there's any, for example, all my customers or students from New York State. So my state field, I'll make it the default value NY. So we don't want the data entry correct to type it always. So if you think any field, it should be default, we can set the default value. Then if any constraints, we should also identify the constraints on the columns. Then we create a table and also the associated indices, if possible. Indices also speed the access of our data. So, as we said, we are not going much concerning here in our lectures. So, again, so this example of creating a table, the syntax, you use the command. So here, all the uppercase are the commands. Create table, the table name. Then we can have the column definitions, if any constraints, if we have to use commit, delete, etc. And the column names, again, this would be the attributes, maybe last name, the data type, first name, etc. If you have any default value for anyone, we can set it also. So let's see example. Okay, one more time, then we see. So this will be an example of an entity, or we call it a ER diagram, entity relationship diagram. So here we were able to identify 4 tables based on the design of the database. And this is just a data model. So we have the customer table, and the attributes are only customer ID and customer name. Now, the field that is underlined and also bold is the primary key field. Then you can see that in the in the order table, the customer ID is a secondary key here. Or sometimes they use the term foreign key or secondary key. So these two tables, customer and order, have a relationship one to many. So when customer do order 3 items, his name will show, his ID and name will show only once here. But in the order table, it will show all the 3 items. So the order ID is uniquely, that's the primary key field. So all the 3 orders, they have different order ID, then all of them will show here. So the customer ID now is a foreign key. So we can repeat it the same as many times as we want. Then along the way, we see that there's a relationship between order and also order line. Also, the relationship is one to many. Normally, the relationship will be the verb. So, for example, here I can say customer places 3 orders, or orders is placed by 3 orders is placed by customer. So the same here also, we can say order contains 6. So it's many, one to many. So it can be any amount. 6 order line. We specify the quantity here. Or we can read it opposite. The order line is, we have 6 is contained in order. Whatever quantity of order line is contained in order. Then also we can say we have a product and order line. So we can say product has many order line, or 3, 4 in the amount. Or the opposite also, how many order line is for product. So again, that's the ER diagram here. Then here we have the overall table definitions. So we create a table based on our ER diagram. So in the ER diagram, again, we don't have all the fields. We just short it up. But here we can see the create table, the name of the table, customer T. Then these are all the fields. We have customer ID, customer name, customer address, customer city, state, etc. And each field, their data type is here. Now, 9, 20, 30 will tell us how many characters we're going to have in each field. Then we make sure that the customer ID and the customer name is important. We make sure it's not known. You can leave that section, those 2 fields unanswered. But address, we can skip it, city, etc. we can skip. Then we create customer ID to be the primary key field. So here we are going to explain only one table because of time. The process are the same throughout. Only in some part we have a relationship. So here we can see, yes, here we can see the relationship. So we have a foreign key, customer ID, references customer T in the customer ID. So the customer table have a relationship with other table. Now, customer ID is here. It's a foreign key now. We assign foreign key to it. And that's here. And also we know the other ID is the primary key field. So that's to create the relationship as we said earlier. Okay, so let's move forward. So this is an example of creating the product table. We have product ID, the data type is a number, not known, and the rest. Now, removing tables, we can use the command to drop table. So if we say drop table customer T, it means we are removing the table. So drop table command statement allow you to remove tables from your schema, or I'll say from your database system. And also we can insert an item. So insert will be part of the data manipulation language. Here we are adding a record now, an actual record. Previously we created table T. Now we say insert into, which is a command, into the customer name and the values. And this have to be entered in the same order as we have the customer T, the fields. So the first field, second contemporary, casual, the address, the city, state, and zip code. Also here we say inserting, here means we are inserting all the table. Let's say the table have 6 fields. Each value represents all the, each value here will go through, it's the same amount as all the fields or the attributes we have. But now, here we say inserting a record that has some null attribute will require that we need to identify the fields that actually get the data. So you can see what we are trying to say is that in this first option, you can see that we didn't identify the fields because if the fields are 10, all the values here also are 10, and it will go in order. If the first field, second field, third field, etc. But now if you are going to leave some fields without the data, now that's the command insert into product T. We specify the column. We have product ID, product description, product finish, product standard price. Then we have the values now. So these values here goes to only the fields that we specified. So here you can see it's less 1, 2, 3, 4. Yes, 1, 2, 3, 4, 5, 6. So we skip 2 fields. Or if we want to insert the data from another table, that's the command. Insert into CA customer T. We use a select command. So we are selecting the data. Select, again, asterisk here means we are selecting all the data. Select all from customer T, where the customer state is California. So if the customer state is California, we are going to select that records. And we are going to set the record into, so we're supposed to have this table already, CA customer. So the command here, what it does is that it's going to get all the data from customer T, where the customer state is California. Then we are going to insert the data into CA customer table. And also delete statements is very straightforward. So that's the example here. Delete means you still have the table. So delete from customer T is different from drop table. Drop table means you want to take delete the whole table out. But here we say delete from customer T means we are deleting the records, but the customer table is still in the schema. Or we can specify that we want to delete some certain records based on some criteria. Here, the criteria is to delete all items where the customer state is from Hawaii. So we want to delete all the Hawaii customers from the customer T table. So we say delete from customer T where customer state is Hawaii or equal to Hawaii. So let's wait for a few seconds if any question. Good, let's keep going. Also, we have a command name update statement. Update statement is we can change any existing, let's say my age is 25 and we put in 15 before. So I can update it from 15 to 25. So here, for example, we use the command update. What you want to update where is in the product T table. So in the product T table, the only thing we're going to update is the fields, the attributes. So we use the command set. Here, the field name is product standard price. So this means we are going to set the product standard price to 775 only for product ID 7. So that means only when product ID is a primary key field in the product table. So if the customer ID product, and also I say customer, if the product ID is 7, then again, we are going to change the product standard price to 775. Okay. So this is where we said very important for this course, select statement. And this is just a few in order. So normally select always will go with select from where. Those are the three, at least select from where. Where will be the condition? But we can say select all from, then we don't need a condition because we are selecting everything. But if we have a specific condition, like say we need students from New York State or students whose grade is GPA 4.0 or something, then we can set it. So select means it lists the columns and expressions to be returned from the query. From will indicate the tables, or if you are using views, where the data will come from. where there should be a condition, indicate a condition under which the row will be included in the result. Then group by will indicate categorization of results. Having will be indicate the condition under which the category or the group will be included. Having, so the command having is almost like English, I have something. Yeah. And then order by is the sorting. So these are the common, again, 6 steps. Select from where group by, having, if it has, if not, then order by, we have all the results, we sort everything out. So order by, we can sort with any of the fields. I'll say order by customer state. So we can also specify, by default, it will be ascending order, but you can change it to descending, it's up to you. So that's the example here. From identifies involve the tables, as we said, where we find all rows meeting some condition. Group by organizing the rows according to the value in stated columns. Having, we find all groups meeting some stated condition. Or maybe having more than $20 or mass value or some condition. Then select identifies the columns, as we said. Order by is again sorting. So we get the final result here. Let's wait for a few seconds if any question. Okay, let's move forward. Again, if you have a question, you can start to speak. I'll just keep quiet, listen to you. As I'm on the slide here now, I cannot see the chat box. So when I finish, then we check it. Okay, so using a select statement, these are the possible for the where condition, these are the possible relational operators we can use. So this is almost close to programming language. So I can say where the product price is equal to or greater than equal to 275, less than equal, or not equal. Not equal, you can use these two arrows, there's no space between them, or exclamation and equal sign, no space between them. So normally we always have 6 relational operators for conditions in any programming language, same concept here. Here also is 6, it look like 7, but because not equal, we have 2 options, which symbol we want to use. So in total is 6. Okay, so select example using the aliases. Also, so we can also use an alias to be another name for, let's say, student table. I also name the student table as a S table. So here we say alias is an alternative column or table name. So you can use the alias as an attribute or the table name also. So for example, here this is select customer name as what? So maybe some of us take Python class. We can see that we use the command as to change a name, especially when we import a package. Let's say import numpy as np. The same concept here. So cost.customer name, we are going to give it a name as a name now. So select cost.customer name as name 1. Then cost.customer address from customer v cost where the name is home furnishing. So it's the same thing, select from where. Here we can see how they use ask command to create a new name or the alias. So wait for a few seconds if any question. Okay. Also, we have a command for, as we said, we have command for min, mouse, count, sum, etc., which we all call them aggregate functions. So here is just an example of using the count aggregate functions to find total. So total, we say select all, but we're going to count it how many? From order line underscore T. So that will be the table where the order ID is this number. So here we say we should know that with aggregate function, you can't have a single value columns included in the select clause unless they are included in the group by. You use the group by clause. So here you can see we say select whatever the counting all. With the count, just say select all from, then basically just print everything. But we're going to again find the total fit count. So let's wait for a few seconds if it's okay. Yep. Also, we have some few Boolean operators. Normally, every programming language also, we always have 3 Boolean operators, whether it's R, Python, Java, the same. So in the script language, you're the same, and or and not. And means I have 2 items. Okay, let me use the term conditions. If the 2 conditions are true, then it's correct. Or means only 1 condition have to be. Or not means to negate. If it's not true, then it's false. If it's not last name, then it's first name. No, it's again opposite. So let's see how they use it here. We say select the product description, which is a column, product finish, a column also, product standard price. So we are selecting 3 columns from a product T, which is a product table, where the product description, we say like percent desk. This is like writing how they call regression. Oh no, the term is gone. But this is like identifying a pattern. So whatever, if DESK is the last, we get it. And also, or product description, let's say computer table or computer desk, then we get it. And product price greater than 300. Now let's look here. Here we are using or. So it means if the product price, product standard price is, so you can, the reason I mentioned product standard, you can see here is N. So the product standard price must be 300. So if the product standard price is 300 and we have computer table, and we're going to get a result. We have computer desk, we're also going to get a result. So in our product description, we need all the desk, different type of desk and different type of table. So here they said the like operator allow you to compare strings using wildcards. For example, percent wildcard, and this indicate that all strings that have any number of characters preceding the word desk. And that's what we're trying to say. So if it's a computer desk or reading desk or any desk you can think of, that's to give. And since this is all, it means whether we have the desk or the table, we get a result. As far as the prices are, the standard price is greater because here is N. So standard, all of them, the price must be greater than 300. So that's how we use the Boolean operators here. Again, here we use the or and. Not is very straightforward. It's to negate or complement. If it's not 300, it means it can be any price except it cannot be 300. Okay. We have another example here, which again is the same concept. We have the product description, finish, standard from product T. Here we say where product description, this or product, and also this. Now, the difference between the two, we can see that we put a parenthesis here, which the same, we put a parenthesis here. This means we must get one result here first, then N. And since this is all, means if it's desk, it's okay. If it's stable, it's okay. If it's stable desk, it's okay. It's all. Okay. Unless it's not a desk, it's not a table, then this will not come at all. Then we don't need this because N means if this is false, even if the standard price is true, we don't get nothing. N means both have to be true. So this section of the parenthesis must be true. Then if we see any price within this destined table is greater than 300, then we get the result. So here we say with parentheses, you can override the normal precedence rule. In this case, parentheses make the or take place before the end. Actually, that's what we should mention. Because you can see in real, let's say, Boolean algebra or something, product will come first before addition. Normally, N is a product and or is an addition. So in the precedency, not come N before or. So if we have it like this, this will still work because we're going to check this condition. And even if we have to check the N first, it goes with these two here. But again, this is more better in the sense that we are going to execute this section first before this section, instead of executing this section first before these two sections. And more examples here. Again, this is order by. So order by is very straightforward. Here we select some few columns from a table. We have a condition. We need Florida, Texas, California, Hawaii. But when we finish, we are going to put the thing in order. We're going to put it in order by customer state field and also customer name. Now here you see that we are using the in operator. Why? Because we have many states. If it's only one state, I'll just say where customer state equal to Florida. But here we say if the customer state is in Florida, Texas, California, Ohio. So here we wrote down here that the in operator in this example allow you to include rows whose customer state value is either Florida, Texas, California, Ohio, all of them. And it's more efficient than separate or condition. Yeah, because so it's like the previous one. So we can say in desk, comma, space, and table. We can also use that. Oh, yeah, also we can say Florida or Texas. Where customer name, Florida or custom of Texas, California. Okay, so enough for the SQL in general. Now we're still coming to the SQL, but this time we are going to see how we can use it with R. So here we say SQL has been one of the go-to solutions for data scientists to perform data analysis and manage data pipelines. Again, here using database management system. Example would be MySQL or Oracle. Here we say this is because SQL is fairly easy to read and learn. Almost everybody knows it. SQL again as a major programming language. Always give the example of Java, or as we see R also. So as a result, it will be helpful for some to work with SQL under R framework. So what is SQL? I will skip that section. We already went through. Now, most important thing is package here. So we have to use the SQL DF package. So here we say we are going to use the SQL DF package to run the SQL queries in R. And SQL DF package is a very convenient R tool that allows us to execute SQL operations on R data frames. And the database here we are going to use can be MySQL if you want to, or SQLite, Post. Again, by MySQL, good news is free. So, yeah. So we can run SQL using queries, again, using the SQL DF package for R. Now, here we say working with SQL becomes very easy in R if we have a good understanding of SQL commands, as we went through the basic already. So let's see our first example here. So first thing we do again is to, if you don't have it, we need to install the package first. So again, using the command, as always we do for installing a package, is the install.packages, the name of the package. Then after we install the package, we have to import it. So we have to use the library command again, which we use a couple of times to import it. So if we have these two commands ready, then we can start now. So that's the sample here. We say first import the SQL DF library. We already installed it, so we just import it. Then we have the read.csv. So we are reading the arrays file, arrays.csv. So we read it into our DF container or the variable. Then next, we say we are going to select all from the DF. So we start with the package name SQL DF. Select all from where you have your data. And wait for a few seconds if it's okay. So all we're doing is what is here. We are going to view the data of the data frame. That's it. Firstly, we import the SQL library, and then we read the CSV files we said. We install it in a DF. After that, we display the data using select command. So we select all from DF. So this will be the result again if we have the file. So this example, so we are going to read a particular column, as we saw in the previous example, from the data frame by inserting a particular column using the same SQL. As we said, using the asterisk wildcard means we select all the columns. This time we are going to select, normally these have 5 columns. We have the pattern length, pattern width, pattern width, and the species. So this is a training data, the species. Based on the 4 attributes here, we can determine normally we have 3 different types of species. So we are going to select only a few of them. So here we decided to select pattern length, pattern width, and also the species from the container DF. So this will show only those 3 columns. So the column name always will be in the square bracket. That's it. There's space, common space between each one. Let's see the results. So we get 3 columns now. The pattern length, pattern width, and also the species. So here in this code also, we are going to use the order by. I think we saw that already. So here we say select. So again, I'm skipping the rest here. We load or import the SQL DF. We read the file. So here what we do again, we select all from the container or the DF. Then order by pattern length. So that's that. So let's look at the pattern length. We can see that pattern length will go from the minimum to maximum. So as we said, by default, sorting is ascending order. Unless you specify DESC, descending, then you change it to descending order, the largest first before the smallest. Okay, if no question, let's keep going. So let's see what we are doing here. So here we're going to select the maximum and also the minimum pattern length, the maximum and the minimum pattern length. So in this case, again, we are going to use the min function and also the max function in the select statement to again get the minimum and maximum. So here we say select max pattern length from DF and also select min pattern length from DF. Again, DF is our container or the content of our data. Okay, so here they say the maximum value is 7.1 and also the minimum value is 4.9. Now, next, we want to delete the data using the SQL statement. So again, we load it, we read our file, then let's see what we are doing here. So we have the SQL DF package again. And first, we just write a string here that we're going to delete from DF where the species. So in the species column, if we see Aris virginica, we're going to delete it. Then after that, we select all from the container. So this result should exclude the species, the column species Aris virginica will be excluded. Oh, that's mine. Okay, right here. Then after we finish, we print the result. Print after delete rows. Then next we display the data frame. Display. So wait for a few seconds. So again, library read.csv, same thing. So when we look here, what we are doing is that we are deleting all the records in the species column. If the column is Aris virginica, we don't want it. Then after that, we select all from the DF. We print after delete rows. So this is just to print the string after delete rows. The result will be here, select off. So normally when you select, you don't need a print. I mean, as we saw the previous example, we say select all from DF and we just give the result. But here we want to print a column here, say after delete rows, etc. But this is the result now. So in this result here means the species we don't have. I think it's Aris virginica. Yeah, Aris virginica. We don't have it. Okay. So these are the possible load packages also that we can use. I think for RS. So here you can see for RS QLite. And also we can use the DBI also. MySQL will take SQL DF. So this is our data. So the previous example now we are doing, and we can see we're using the CSV, comma separated value file. So same as most programming language, if you want to use a database system, we need to do a connection first. So database connectivity. In Java, we call it a Java JDBC connectivity. So first, this is okay. We just want to get our first few records, and that's the result here, the head Aris. Now, this is the connection. So first we start with the DB connect. We are using the SQLite with, and we assign to the connection. Then we have the DB write table argument. Again, by default, we use the connection and the name, in this case, Aris. Then DB read table, the connection again, and the name where it's reading Aris. And the result will go to our container here, Aris TBL or table. So what we are doing is that we are connecting our system, or in this case, the R application, to the database system. Database system, there's two things we can do. Either we write to it, which means we save the data in the database, or we read from it, which means we get data from we get input from there. So read is to get input, write is to store data. So that's the first thing we need to do here. Then after that, again, we can do whatever. In this case, we are selecting all from Aris again, and we need a limit of 10. So this will give us 10 items. Originally, the Aris have 150 records. 50 for Setosa, 50 for Virginica, and then there's another one. Forget it. Again, three different categories. Okay, so if no question, let's keep going. Okay, so that will be the conclusion here. Again, here to just give us some introduction to the concept of using, again, R with a database system. So wait for a few seconds. If no question, then we're going to take our short break now. It seems like we almost 1.5 hours now. Okay, so if no question, then let's take a short break.